Magnavox presents Odyssey, the electronic game of the future. Odyssey easily attaches to any brand TV, black and white or color, to create a closed-circuit electronic playground. Odyssey gives you all the exciting action of hockey and 11 other challenging play and learning games for the entire family. Odyssey, a new dimension for your television, now at your Magnavox dealer. He's listed in the yellow pages.
I've told this story before. Almost 3.5 years ago now, when the channel was brand spanking new, I made an introductory video talking about who I was and the purpose of the channel. Then I showed my Magnavox Odyssey. I did a little teardown, talked about how the Odyssey came to be and why it was so important in the history of computing and gaming. I do not recommend going back to watch that video. I was a complete noob and it was very obvious. Since I've already told the story once, I'll try to keep it brief this time. German-born American engineer Ralph Baer, around 1951, had an idea. He saw how television was spreading through society, feeding information, entertainment, and education directly into people's homes. But he thought it could be much more interactive and engaging for the consumer. It would take 15 years, but in 1966 he made a pitch to his employer, Sanders Associates Incorporated, to allow him to develop his idea. He was given a budget of $2,500 US and the time of two other engineers, Bill Harrison and Bill Rush. Together, they developed the first commercial gaming unit, the Brown Box console. Sanders Associates, however, had neither the marketing nor distribution channels to properly market the new console. Baer shopped the product around to several corporations before he finally got interest from Magnavox, who saw an opportunity to sell the console alongside their televisions. They redesigned the aesthetics, renamed it the Magnavox Odyssey, and the rest is history. Today, Ralph Baer is considered the father of video games. He went on to develop and patent several other games and consoles, including the popular pattern-matching game Simon. At the time of his passing in 2014, he had over 150 patents registered in his name. When I made my introductory video, I didn't try to power the console on to show it working or to make any repairs. I was afraid to. That was very early in my learning journey, and I knew I didn't have the skills necessary to fix anything that was broken. I probably still don't, but we're going to try this together anyway. I'd like to exhibit this console at a potential upcoming vintage computer show. That show's still in the planning stage, so it's not definite yet, but I'd like to be prepared in case it actually happens. I'm still scared of this machine. Its components are over 50 years old at this point, and there's very likely been some deterioration. Add to that some very cryptic Magnavox-specific part numbers in the service manual and schematics, and sourcing replacement parts might become very difficult. Then there's a simple fact that this machine is very much outside my scope of knowledge. There are no integrated circuits at all. The machine's entirely made up of discrete components. No CPU, no memory, either short-term or long-term, no code. I don't even think anything in it can be truly considered digital. It's all analog alchemy, which I don't truly have a proper understanding of. Hopefully, with a lot of research and a huge amount of help from you out there in the community, I can learn enough to fix any faults and get it running. I am going to try to apply what little I've learned over the years and take as systematic an approach to this as I can. I'll start with disassembly, cleaning, and inspection before ever applying power. So I don't expect anything too exciting or explosive to happen today. But let's go ahead and get stuck in and see how far we can get. So let's talk a little bit about what I have and what I don't have. I do not have a complete in-box Magnavox Odyssey. My parents picked this up at a yard sale, garage sale, when I was 10 or 11 years old and gave it to me. They had no idea what it was. And frankly, as a kid that young, I had no idea what it was or what its significance was. I played with it, and as kids tend to do, I lost bits and pieces. And then it was stored away in my parents' attic for many, many years. and more of the bits and pieces have gone missing. I no longer even have the original box or polys. I have only a few of the accessories. Now, this came with game cards, it came with controllers, it came with the video cable, it came with a switch box that you would attach to the back of your TV. I call these game cards, but it came with gaming cards, cardboard cards that you'd use to play the games. It came with fake money. It came with gambling chips, because one of the original games that you can play on this is roulette, so you can bet with the chips. It came with cardboard scorecards that you would use during gameplay, and it came with overlays. These overlays, these Mylar overlays, would attach to a television screen. You got two sizes: size for smaller TVs, which is this one, and a size for larger TVs. And you would stick them to the front of the TV, usually using the static electricity that was generated by the CRT. Of course, if there wasn't sufficient static electricity, you could simply use Scotch tape and tape them to the television. And these provided the field of play for the games. I have only a small number of those. I have mostly the large ones, and I don't have a large TV for this to go with. I have a smaller TV that would use the smaller overlays. So I'm missing quite a bit of the set, but I have the electronics, the basic electronics. Now, there are some things that we're going to run into that are problems. One of them is the video cable itself. Now this, as you can see, is not a standard RCA connector. There's no shield around the outside of the center plug that's ground. I think we've got an inner and an outer that are the signal and ground. So we're going to have to work around that. I no longer have the switch box to connect it to the television, so I don't have the switch box would have the proper jack for these to plug into. Of course, there's the jack on the back of the Odyssey. So we're going to have to deal with some of that stuff. So I have the original 6 cards that came with the console. If you'll notice, one of the cards is a little bit different color, and that's because I had to find one of these on eBay. I had 1, 2, 3, 4, and 6. I did not have 5, so I bought a 5. And what these cards do is they complete circuits within the machine. So there's no ROM on these as there are for later cartridge games. The first actual cartridge game, in case you're unaware, was the Fairchild Channel F. I'd love to get my hands on one of those. They are available. They're a little pricey. But all these cards do is complete circuits between the pins. In fact, one of the circuits it completes is the power circuit. The way you turn this machine on and off, there's no switch. When you plug one of the cards into the console, that completes the power circuit and gives you power. I also have, I don't know where I got these, I also have several additional game cards. There were more games that were available for the Magnavox Odyssey that you'd buy separately, and they often came with their own game cards if they couldn't do what they needed to do with the cards that were already in play. And I have a number 9 and 2 number 10s for some reason. So, as I said, I have the original 6 plus those 3. Now we're going to set these aside for the moment. The controllers, you'll see, are very different to anything you might see in later games. You had the ability to move your player horizontally and vertically and apply English to the ball, and then there's a reset switch. And these controllers connect to the console through a very chunky cable and a very chunky plug, which, as you'll see, is very different to anything that you'll see today, or that you've seen for the past 50 years. These were very unique. So we may have to take a look at the internals of the controllers if things aren't working too well. So we'll set the controllers aside. The console itself is a nice thick plastic. It's very well made. This plastic doesn't seem to have become particularly brittle over the years. You'll see the ports on the back. This is where your player 1 plugs in, your player 2 plugs in. Accessory, the only accessory that I know of that I think goes in here is there was a light gun that you could buy for shooting games. The game cord, it says here, is the video cord that goes to the switch box at the back of the TV. And then you have center and speed controls. The center control moves the wall that would go down the middle of the screen, moves it left and right to adjust it for the size of the television that you're using. On the back of the console, the only port is the external power port. Now, this did not come with an external power adapter. You could buy one. It looks to use a 2.5 millimeter plug. I'm not entirely certain about that. But the way you would normally play this is this was designed to use batteries, and the batteries go in this compartment back here. This console took 6 C-cell batteries, not something you see commonly today. You can still get them. We may, when we go to power this up, we may try it with the batteries, but I can also feed it directly 9 volts from my bench power supply direct to the board inside. Now, this is a model 1TL200 finish BLAK. This is run 2, so this is the second run of the Odyssey. There was a first run, and then run 2 came later. Made in the USA, got an FCC ID. Patent numbers are on here. And that's the bottom of the console. This is serial number 9499742. 120 volts, 60 hertz, which makes no sense because you're not feeding it AC, but it's there. So, that's our console. The next thing we need to do is open her up. As I said, we are going to disassemble, clean, and inspect the machine today. We won't be doing any repairs or attempting to power the machine on. There are, I believe, simply these 4 screws that hold the console together. You have to remove the control knobs at the back to get it to come apart. Now it should come loose. Yep. The interior is a bit dirty. It had these foam pads which have disintegrated and created a lot of dust. So we'll have to clean this all out and give it a scrub. Now we can get a look at the interior of the console. We have the battery compartment here, and the main board and all of the daughter boards. Each of these daughter boards has a specific function. One is player 1 control, one is player 2 control, ball, wall. Some of the cards handle when the player or the ball or the wall contact each other and activate flip-flops. Others are the flip-flops. This is the horizontal sync generator, and the vertical sync generator is this one. All of those boards then send their output signals, including the horizontal, vertical, the ball position, the player positions. All of those send their signals to this card here. And this card here is called Summer. Now, I thought at first, being the idiot that I am, I thought that was one of those cutesy little names for a part like the Antic or the Agnes or Pokey. But no, what that actually is it sums the video signals together to create a composite video signal, which is then fed into the RF modulator, which is inside this can here. So what we need to do is we need to remove all these daughter boards and label them, or make sure they're labeled so that I don't put the wrong board back in the wrong slot. This is flip-flop, and it's labeled flip-flop on the board. It's labeled flip-flop on the card. So as you can see, we're all discrete components. There's no ICs in here at all. We've got transistors, we've got resistors, we've got capacitors, and wow. If you look closely, I don't know if you can see this. I'll try to let you see. If you look closely at this board, you'll see that they've left the legs quite long, and that's unusual in my experience. However, I have seen other people take Odysseys apart, and that seems to be a common theme among them. So what we will do is we will pull these boards, we will clean them, and make sure they appear to be in good shape, and before we ever try to put this machine back together and power it up. So here's flip-flop. This is gate matrix. This one is spot generator, in this case player 2. I am going to go ahead, and since it just says spot generator, I want to make sure I put it back in the same place, so I will label it using a Sharpie, which should come off with IPA. This one is the ball spot generator. These are very stiffly in these connectors. I will, of course, deoxide them before putting them back in. Hopefully that'll make this an easier job if I have to do it again in the future. This is another spot generator. I'm going to call it B for ball. I believe the spot generators are mostly identical. Not 100% certain of that. This one, the horizontal sync generator, that's labeled. This is summer. And it's labeled summer. This is the wall spot generator, so I'll label it W. This is the English flip-flop. You can apply English to the ball to control it. And here is the player 1 spot generator. I hate putting this much force on these old boards, but it's the only way to get them loose. There we go. This is P1, and this is the vertical sync generator. Okay. Now those sync generators, horizontal and vertical, I have read are asymmetric multivibrators. One at 60 hertz and one at 15.75 kilohertz. Now we have adjustments in here for ball height, for player width, ball width, horizontal frequency. There's a crowbar circuit, which causes the ball and player to disappear at coincidence. That circuit's on the master board, so it's not one of the daughter boards. The RF filter is in here, the RF oscillator is in here, Some hex head screws that hold the main board into the chassis. Yep, it's just those four. Remove the battery terminal. When we do eventually go to test this, I should be able to connect directly to these two pins to provide it the 9 volts from the external DC power supply. All right, there is our board extracted. So, what we have to do now is give this a good clean. It's dusty, dirty. There is potentially some cap leakage. I am going to do a full electrolytic recap. I've got the caps on order, at least for the main board. There are electrolytics on this one, the horizontal sync generator. The vertical sync generator has, I believe those are polymer caps, so those won't need a recap. But I will get these replaced. But, as I said, our next step is cleaning. While he's doing that, I need to ask you for a favor. I've never charged anyone for access to the videos on my channel. They've always been free to view, and that's not ever going to change. Some folks have chosen of their own volition to offer me some support. That said, this hobby isn't cheap. Broken devices are getting more and more expensive as time goes on. Replacement parts can cost a pretty penny, especially if they're OEM, and even shop supplies like IPA and Deoxit nickel and dime you to death. I'll also be attending VCF Midwest for the second time in September, and though admission is free, hotel, meals, and travel aren't. I'd also like to attend more of these types of events going forward. So what I'm asking is that if you're so inclined, maybe you could consider supporting the channel in some small way. There are 3 mechanisms available to do this. YouTube channel membership is the first. You can do that by clicking the button below the video or using the link in the description. The second is Patreon. You can find my Patreon page using the link that's also included in the description. And third is Ko-Fi, also linked in the description. If you've looked at these options before and were turned off by the tier prices, they've been reduced. I now offer the same tiers on both Patreon and YouTube channel membership. The lowest tier is now only $2, with $5 and $10 higher tiers. You do get perks like early access and ad-free access depending on the tier, so I hope you'll check them out. Again, to reiterate, nothing is changing and you absolutely don't need to join to keep watching my content. I'm just hoping you like what I do enough that you'll feel a little spirit of generosity and jump in to help out. Now I'll let you get back to watching the guy on screen clean the Odyssey. Thank you for your attention. Alrighty then. So I've completed the basic cleaning. I used QD electronic cleaner and isopropyl alcohol to go over the board. I first blew off the dust. I had originally planned on doing a warm water and soap wash, but I decided not to do that because 2 reasons. One is this board is old and potentially fragile. The other reason is all the potentiometers. I didn't want to get water and soap inside the potentiometers, so the best way to do that was to use a different cleaning method, and I decided to use the QD electronic cleaner. QD meaning quick dry, and it is that. It was drying almost before I could use it, but I did go over the entire board with the QD electronic cleaner and isopropyl alcohol on the back, and the board's in much better shape now than it was.
So let's go over it using the microscope and take a look and see if there's any obvious damage or if there is any corrosion that might potentially pose a problem. So we are in the upper right corner of the board right now. You'll notice that jumper link right there looks pretty corroded. However, it is just a jumper link, so that shouldn't be an issue. We move down the board. I have some diodes. Again, there's some corrosion on the leads, but I don't think that'll be a problem. If it's gotten inside, which it doesn't look like it has, but if it's gotten inside those diodes, they may have to be replaced. We'll see one of the daughter board connectors right here. Now, I will be, when I do the maintenance section, where I replace the capacitors and other preventative maintenance, I will be cleaning the card connectors with deoxit to clean and lubricate them and make sure they're making good contact for the future. There's another of the connectors. More diodes. There is one of the potentiometers. We will be cleaning those with some deoxit fader lube. More jumper links. And another connector out here. Another jumper link. There's an electrolytic capacitor. Resistor, another potentiometer. The jumper links, just FYI, this is a single-sided board with all the traces on the back. The jumper links connect the traces on the top side. Some wiring that goes from one side of the board to another, basically longer jumper links. There is still some gunk. The wiring got a little sticky, and some of that foam that disintegrated got stuck to it, but that's not, it's a cleaning issue, but it's not a functional issue, so we shouldn't have to worry about that. The leads on the resistors that look a little corroded, they are. Again, if that corrosion's gotten inside, it could cause an issue, so we may have to replace some resistors, but we'll check all that later. Another potentiometer. A large ferrite bead. Resistor and electrolytic. Again, as I said, I will be replacing the electrolytic capacitors, so if you see any leakage around the electrolytics, which that might be right there, I will clean that up when I have the capacitors off the board before installing the new ones. That is, is that the speed potentiometer? Ball speed potentiometer right there. Again, I'll be cleaning those with fader lube. Another diode, one of the transistors, two of the transistors, I should say. Transistors are the main point where we have, I mentioned, cryptic part numbers. The transistors have Magnavox specific part numbers, and there's no cross-reference, so I have found references to people replacing them and what transistors they've used. So if we have to replace those, it may be possible to simply replace them with common components. Here is the wall position potentiometer. If you're wondering about that stuff that looks like it's wet around all the components, I believe that is factory flux, and I was unsuccessful in cleaning that off. So hopefully it's not doing any damage, but we might have to dig a little deeper into that. This is the channel selector switch. These two transistors, see if I can get a better view of them. I'm concerned that they are between two large electrolytic capacitors that could have leaked. And if so, we might see some corrosion on the pins, but no, those pins actually look clean. Yeah, they're good. Battery terminals need a little cleaning. This is the game card slot. Again, it'll get deoxided. More ferrite beads. Okay. Well, that covers the board, main board. I don't see any obvious damage, and the corrosion is at a minimum and seems to mainly affect the jumper leads and the legs of a few components. Hopefully those components are still intact. So let's take a look at a few of the, well, let's take a look at the daughter boards. So this is one of the flip-flops. This has no electrolytic capacitors on it. Transistor legs, those look good. These odd little transistors. Legs on those look good. So I think the flip-flop looks good. Here is summer, and this is just diodes and resistors and small passives, so no transistors, no diodes. These blue things are diodes, apparently. The diodes and resistors is all that's going on here, and those all look okay. So summer looks good. The other flip-flop, this is the English flip-flop. And that looks good. And the horizontal sync generator. Again, this is, I said this wrong earlier. This is an astable multivibrator. I think I said asymmetric multivibrator earlier. That's not correct. Astable multivibrator. And again, we've got these transistors, and there you can see one of the obscure Magnavox specific part numbers, 142 and 9. So if we have to replace those, we'll have to do some cross-referencing and figure out what to replace them with. The legs look good. These capacitors, I believe, are polyester capacitors. So they there is a little bit of corrosion on the pins of that transistor. So we'll have to keep that in mind. See if we can clean that off with some vinegar, and hopefully it hasn't gotten inside the package. Not sure what would have caused that. The polyester capacitors should not have leaked. And the legs on the other transistors look good. So that's the horizontal sync generator. This, I think, is, yeah, this is, or that was vertical sync before. This is the horizontal sync. This one does have electrolytics on it, so that could be an issue. Let's look at the legs of this transistor. Yeah, that one looks good. Not even sure what that is. I think it's a capacitor of some kind. No, it's an inductor, L1. They're capacitors. They don't look like they've leaked. I'm not sure what type of capacitors those are. Possibly a little green crusty on that transistor. I don't think it's gotten to the package. We can clean that with a little vinegar. And now, oh wait, one more before we get to the spot generators. This is summer. What was? Oh, that was gate array. This one that we looked at before was gate array or gate matrix. This one is summer, and it's just resistors and diodes. And it's looking fine. Now the spot generators. These do have what I believe is an electrolytic capacitor. It's just a shape that I've not seen before, a form factor that I've not seen before. They say 0.15 without a units designation, but I believe I've figured out that these are 0.15 microfarad, aka 150 nanofarad. Electrolytic capacitors, 250 volts. And if we look closely at the legs of the transistor sitting right next to it, we've got some green crusties, so we probably have some leakage here. I will order these and replace them. And again, we'll have to make sure that that transistor is still good. Some green crusties on that transistor as well. And on that one. And that one. So this electrolytic appears to have leaked quite a bit. Okay, that is the wall spot generator. This is the player 2 spot generator. Yeah, some green crusties on that transistor. And the one next to another form of electrolytic capacitor that I hadn't seen before. Definitely green crusties there on that transistor. Those transistors may have a little bit, but they don't look as bad as the one in the corner here. Okay. This is the ball spot generator. That transistor looks all right. That one looks all right. As does that one. This one, however, has some green crusties. So this electrolytic here has probably started to go. Okay. And lastly, the player 2 spot generator. those transistors look mostly all right. No green crusties that I can see on that one. No green crusties on that one that I can see. But there's green on the board, so there's a good chance that capacitor is leaking as well. All right, that's all the daughter boards. So, next time. This time we did disassembly, cleaning, and inspection. The next time we will be doing preventative maintenance, replacing the electrolytic capacitors, verifying that the transistors are good, cleaning up some green crusties from some of them. We may do a little more work with vinegar, cleaning off some of the corrosion on the main board. And if we're lucky, we may get to the point where we can go ahead and try powering this thing up. So, thank you for watching, and thank you for your support. If you enjoyed this video and you haven't already, please subscribe to the channel. I can always use more subscribers. The more subscribers I have, the more reach I get, and the more YouTube will push my videos out. If you liked the video, click the like button. If not, you know what to do there too. Please leave me a comment. I love interacting with you guys, but if you are going to leave a dislike, it'd be really helpful to me if you would go ahead and in the description let me know what it is you didn't like about the video so I can try to improve for the future. If you're an expert in these analog electronics, definitely please leave me a comment so I know how to get in touch with you as I go through this, because I don't know how most of this works, and if there are problems with it, I'm going to need help from people much smarter than myself. Share the video to your friends and your social media, and join me and everybody else on the Retro Hardware Discord. I will be putting a link to that in the description below. Also, there is yet another Retro Channel Discord you can join if you'd like to. And again, if you want to support the channel, I would greatly appreciate that. You can do that a few ways. I do have a Patreon, and that's linked in the description below. If you want to join the YouTube channel membership, there is a button right below this video to do that. And there is also a link to buy me a coffee. So I would appreciate any support you can offer me. This hobby is not a cheap one. I do it for myself, but I also do it for you guys. And I don't charge for it. I don't force you to pay to watch my videos, but I can definitely use the support. This stuff does not come cheaply. The machines that I work on, the equipment I use, and the supplies do not come cheaply, so I can always use a hand. But I think that'll do it for today. So everybody be well, stay healthy and safe, and have a great week, and we'll see you in the next one.